So from my point of view, artificial intelligence has a lot of benefits, but it also comes with several downsides, I would say. I do not think that artificial intelligence is applicable for cloud security exclusively. It rather applies for the whole spectrum of application security and so on. I would say so, not exclusively for cloud security, but the big advantages from my point of view is it can analyze huge amounts of data. It has advanced recognition capabilities in the area of pattern recognition, anomaly detection, and so on. And therefore, it can help a lot in the area of threat detection from my point of view, and also advanced threat detection, especially when it comes to the area of sophisticated threats, advanced persistent threats, and so on. They very often leverage sophisticated attacks which cannot be detected that easily. And with the help of AI tools, it might improve in the future to detect especially zero-day exploits and such intrusions a bit more easily. And the same thing goes for automation and orchestration. With the capabilities of AI to take certain decisions on their own and learn somehow things, it makes it maybe a lot more easier to automate stuff in the future and orchestrate certain responses to attacks. So I would say the benefits are enhanced threat detection capabilities for sure, and also automation orchestration, but they do not come exclusively for the defender or protection side. They are available for the attacker side as well. And that is maybe also one of the risks. Attackers and threats are already leveraging AI to also perform some analysis, some detection, vulnerability detection, and automating their exploits and the lateral movement within environments. When you use AI tools, you have another system you have to protect. And those tools, especially when they get higher privileges, they can become a target themselves. And when those machine learning models and artificial intelligence models running in the background are poisoned, then they can create false positives, false negatives, and they can basically work against you. On the other hand, they might provide or reveal sensitive data based on their training data. So those tools can become targets themselves, and it is really important to carefully use them. And on the other side, there's also the huge risk of the over-reliance on artificial intelligence tools, meaning that you have implemented an artificial intelligence tool and you fully rely on that without having the human experts on the other side, which are able or who are able to fine-tune the configurations, make it sure that it does its job properly, or in the event that some AI model is poisoned somehow, can take over the work and respond to the incident themselves. So it can only be a proper and good tool when you use it combined with the human intelligence, the human expertise, and then it can be or will be a very valuable tool for the future. But as I mentioned under the bottom line, it brings the huge advantages in the area of detection, automation, orchestration, but it brings also those advantages to the attackers. And it has to be used carefully, and it has to be prevented to over-rely on those tools and fully leaving out the human expertise. It can bring more speed, but at the same time, you need humans who are still capable and have the expertise to work with those tools and fine-tune and make sure that everything works as it should. Well, of course, I cannot speak for Siemens as a whole. It's a large company, and Siemens has very mature cybersecurity processes and strategies in place already that apply to the different areas Siemens is working on. But I can share some of the insights or in the area of responsibility I'm working on and what I try to achieve together with the colleagues and the experience I want to bring in within the environment I am working in. So when it comes to cloud security at scale, I think the most important thing is to keep in mind that when you look at the numbers, cloud technology spendings compared to traditional server hardware spendings, you can see that cloud has outcompeted traditional hardware spendings since several years. The same goes for the spendings on cloud services. They increase year over year. Cloud has to be considered no longer something out of the ordinary, but cloud is rather a commodity that's available out there on the market, and it's rather the new standard, especially for huge corporations, global companies, And therefore, the cybersecurity staff has to be aware of the fact that it's the most important asset they have to protect. And when it comes to cloud security at scale, I would say the most important thing, at least what we try to achieve, is having a very strong and secure baseline from which you can start, and then you can start to improve and increase the maturity. So what do I mean with that? I mean, when new cloud security projects start, or you have transformation projects of application you want to bring in the cloud and so on, you need to make sure that they start from a security by design approach. You need to have proper and skilled experts within the teams when they design the architecture to make sure that security principles are applied from day one. And from there, you can make sure with a very strong baseline, a toolbox in the best case, and templates available, that all the important measures are implemented from day one, at least to have the most important protections in place, meaning proper identity and access management from day one, maybe applying already zero trust principles from day one, and introducing separated networks to make sure that the blast radius of an attack is contained already by the architecture design that is taken. And when then the development starts and everything is deployed into the cloud, you, in the best case, have a standardized toolbox available, that the CI/CD pipeline is protected, that you have proper vulnerability management within your cloud environment, that you have maybe when you already run some kind of data or sensitive data in your development, that the data is encrypted properly. You have, as I mentioned, network segmentation in place. You have some kind of configuration management in place, and make sure that in the best case, everything is deployed as code. And then you can make sure that the basic rule set is applied to all of your cloud accounts, cloud environments, cloud solutions. And from there, then you can start upscaling to higher maturity levels. And the important thing is that then the things which are newly developed, you have, especially in large corporations like Siemens or the other global corporations, many different areas, people working on similar things, and you need to make sure that those things are somehow shared in the community, somehow that there's a kind of knowledge sharing, that things are not solved many times, but rather once and then scaled across the company or across the department, that the people who have already found a solution prepared some kind of standardized way to implement it into the other projects as well, that nobody needs to reinvent the wheel each and every time, but everything is shared, and then you can start upscaling to address the higher things. And another very important thing is to start from a risk-based approach, I would say. First of all, in the architecture phase, think of your risks, think of the impacts those risks have, and then start implementing those measures which have the highest importance, the highest impact first, and then gradually scale towards the less significant risks and mitigate those, define the solutions, share them again with the community, and gradually start scaling and becoming faster across the company. So, as I already mentioned, cloud is no longer something out of the ordinary. Rather, cloud is the new standard, and especially in big corporations, cloud environments become more and more common. Therefore, attacks on cloud environments become more and more common, and there's data indicating, and things we have found out, or also I worked on a bit, attacks by sophisticated attackers on cloud environments become more common. So what I expect in the future is that those attacks on cloud environments will increase even further. I expect that also the impact of those attacks will increase because it's just a much more attractive target in the future. On the other hand, examples like SolarWinds have shown that attacks on the software supply chain, compromising certain tools many companies are using, makes it for attackers much easier to heavily increase their return on invest. And therefore, I think those things have to be addressed by companies in the future even more. The impact of data breaches will increase. The attacks on the software supply chain and cloud environments will heavily increase, and also the usage of new technology. Now it's artificial intelligence, but in the future, things are on the verge like quantum technologies and so on. And all those things will be leveraged by the attacker side, especially sophisticated attackers. But companies have ways to address those risks already. For instance, more heavily focusing on zero trust, more heavily focusing on confidential computing, for instance, meaning that encryption is even in place when data is computed. The application of microservices environments, more heavily using serverless technologies, because then you can just replace a compromised function maybe with a new function, or containerizing these things. Those things are already in place. The same goes for quantum safe encryption algorithms. And when companies are aware of those emerging trends and aware of the fact that cloud attacks will increase in the future even more, then they can already consider that in their risk evaluations and protect, for instance, their sensitive data already with quantum safe encryption algorithms. They can make use of artificial intelligence tools, as I mentioned, that can help, especially sophisticated attackers. As I mentioned, leverage zero-day exploits. Artificial intelligence tools help to detect anomalies, have better capabilities than humans have to detect, to recognize certain patterns attackers use. And by leveraging these technologies, these new tools like artificial intelligence, considering quantum safe algorithms when it makes sense, and applying principles which are already out there on the market, like zero trust, they can address the trend, which I think is going to emerge even further, like more cloud attacks, more sophisticated attacks, and more breaches on the software supply chain. And everything combined then maybe and enhance with software bill of materials, which make it then even easier to see if a third-party tool was compromised, or a third-party package, library, whatever, to contain the things faster. Leveraging AI for those tasks will help companies to address these emerging trends. Yeah, so first of all, I'm looking forward to an interesting event. I look forward to very interesting talks, to meeting interesting people, to have some interesting conversations and getting new perspectives. And at the same time, I'm looking forward to sharing my experience, to sharing my insights with my talk, getting some feedback, getting some new insights, and then improving from there, seeing things from a new perspective and exchanging with very interesting experts and very interesting talks I already have seen on the agenda. So I'm looking forward, under the bottom line, to a very interesting event with interesting people, having some nice conversations and sharing my knowledge and getting some feedback there to improve the things and seeing new perspective.